Hey everyone, welcome to today's webinar, co-hosted by the New York Oracle User Group and Oracle partner, Viscosity North America. My name is Monica and I'm the Marketing Director at Viscosity. If you're not familiar with us, we are a full Oracle stack consulting firm with a core expertise in Oracle database, including RAC, Apex, zero downtime migrations, performance tuning, high availability, you name it. We've got decades of experience with infrastructure and engineered systems, and we are one click away. If you need anything, please email us at hello@viscosityna.com, and me and my team will follow up with you today after today's webinar. So during our webinar, feel free to submit any questions at any time to our presenter, Craig, in the question or chat prompt that you should see around the lower right side of your screen, or if you've got the GoToWebinar control panel up. So today's webinar is by Craig Shalahammer, and representing NYOUG today is Coleman Leviter. Coleman's going to introduce you to NYOUG and then also to Craig.
Thank you, Monica. Good afternoon, everybody, or good morning, everybody, depending upon your time zone. Welcome to our webinar series co-hosted by Viscosity and the New York Oracle Users Group. We've been around since 1984 for the exchange of ideas of Oracle products. Connect with us either on Twitter, Meetup, LinkedIn, Facebook, and our website, nyoug.org. And of course, also outreach to our members at community.oracle.com at community user groups. And just a thank you again to Viscosity North America and for co-hosting this webinar series with us. And I'll introduce Craig. He's president and founder of AuraPub with over 30 years of experience in consulting, training, and tool development in analytics, machine learning, and Oracle database performance for hundreds of companies around the world, including Oracle Corporation. Craig holds a Bachelor of Science in Economics from California Polytech and is an Oracle ACE Director. Again, thank you, Monica. Thank you, Craig, for this webinar series. And I'd like to introduce Craig, and please go ahead.
All right, so can you guys hear me and see my screen? Can you see my screen there? You can? Okay, good. I started this presentation last week and screen wasn't shared for about 5 minutes. It was a bummer. So, hey, welcome everyone. My name's Craig, and we're going to talk about machine learning today, but it's kind of an upside down way to actually talk about it. And I thought, wow, this is really creative, great way to teach people about machine learning, especially if you're in this kind of situation that I'm going to be that I'm going to talk about right now. So, all right, so just sit back and relax. This is going to be about half lecture and half demo. So that'll be a lot of fun here because there's always risk whenever there's a live demo and it's not recorded. So here's the situation that, like, those of you that I'm really speaking to right now is that, you know, machine learning is like all the rage, right? I mean, you hear about it all the time. It's actually kind of irritating. Everybody's into it, you know, and all the other departments get to check it out, right? Sales, marketing, geological research. I mean, anything. You can apply it to so many different areas. And of course, you know, we want to get in on the fun, right? But we're in IT, and IT is not known for a lot of fun stuff sometimes. And so while some IT organizations are actually investigating how to use machine learning, yours is not actually doing that, and they're not even considering that. But you're still asked, and you're still responsible to monitor, right, a lot of Oracle systems, both big and small. And so you kind of look around and you're like, you know it's not sustainable. You can't keep being asked to monitor more and more systems more effectively by using rules, kind of old technology. And so, and machine learning is one of the answers to actually help you scale. And so you're wondering, like, are you the only one in the organization that actually sees that? So you might have asked, okay, I'm not trying to be sneaky or anything like that, but is there a way that you can, like, investigate machine learning in your work, even though your department or division or whatever is really not interested in machine learning? Well, of course, the answer is yes, because that's what the presentation is all about here. And so one solution is to use machine learning in like stealth mode. So what this presentation is about is how can you use machine learning really without others kind of, you know, hey, what are you doing, man? You can kind of just learn some stuff in the stealth mode. And so let me explain to you how this could be possible. So currently your monitoring and alerting system, they're probably all rule-based. I mean, that's how it is right now, okay? But what if you could actually use machine learning to create the rules for you? That's the question, all right? Now, it's interestingly enough, when you use machine learning decision trees, which is what I'm going to get into today, they are essentially a bunch of if then else statements that we get from this tree that's actually built out. So what if we could actually use machine learning, these decision trees, to generate the if then else statements, and you could actually take those and actually put those in your existing monitoring and alerting systems. In fact, you can even have what I'm going to show you create like the code, PL SQL or whatever you want, and perhaps you can literally copy and paste some of this actually in your existing system. Who knows? But I think you'll get the idea and the concept. Now, what I'm going to show you is actually really straightforward. I'm going to show you a couple different use cases. But there are some tricks though, okay? So I'm not giving you enough to actually deploy this, but it should get the wheels turning and you start to think about the possibilities. And that's really what I'm going for in the presentation today. So can we actually do this though? Yeah, of course we can do it. And I'm gonna give you the core building blocks so you can actually get started and actually be kind of dangerous, all right? Seriously. So, but before I do that, I'd like to introduce myself just real quick because Coleman actually did an amazing introduction. So yeah, I'm a longtime Oracle DBA and my background has been predictive analytics, capacity planning, machine learning, which takes us really to the next level, and Oracle performance tuning. I do a lot of performance research and I put that information, that detail in my blog, author of a couple books. I do a lot of conference speaking, mentoring of Oracle DBAs. So I'm an Oracle ACE director, which is awesome. And I'm really involved in Oracle user groups. And I've been the DBA track manager for IOUG user group for a bunch of years now, and which IUG and the Quest user group, not Quest, the company, the user group has merged with IOUG. So hopefully we'll have a conference, live conferences here. That would be actually be super cool. So OraPub, the company, is all about Oracle performance, whether it's firefighting, whether it's machine learning, whatever. Okay, and so the whole website, the whole company is based on empowering and equipping primarily Oracle DBAs and developers so they can really take those skills to the next level. So there's tons of free stuff on my website, but those of you that actually want to like get serious, we have a membership program, different levels, and that's where all my Primo content is released through that. So if you're interested in that, check it out on my website. Okay, the last thing I want to mention is if you're new to machine learning, or it's like you're not even new, you're just like, what is this? And you're kind of curious. I created like an e-course. It's 18 sections. Each section is a short email with some actual Python code you can copy and paste into Python, and you can learn about machine learning. It's super cool, and it leads you through it step by step. Doesn't take a whole lot of time, but it should be fascinating. And if it is fascinating and you're like, wow, this is cool, then that means you're actually interested in machine learning. And I created the course because some of you are going to go through that and you're going to say, this is awesome. Some of you are going to say, I don't care about this at all. And so I created this so you'll know really quickly with minimal effort if there's something that you actually want to focus on. So that's the URL. I'll put that in the little chat box. Oh yeah, if you have any questions, just go ahead and chat those in. If I see them, oh, I don't know if I can chat. Can I chat? Oh, it won't let me do a paste. Oh, that sucks. Okay, www.orapub.com/ml. That's an L. Okay, ML-e-course. Fill out a form, boom, you'll get the first lesson, hopefully in minutes. Okay, so let's do some machine learning. All right, the first thing we need to know in machine learning, we have AI, And one of kind of the pillars of AI is machine learning. There's a bunch of other technology like voice recognition, stuff like that. So machine learning, you hear it interchanged with AI, but it's just a part of AI. What's important to us today, though, is that when you break down machine learning, there's really only two fundamental ways we use machine learning. We develop models based on algorithms. The guys at MIT, those guys write the algorithms that we actually use to create predictive models, okay? So we're like applied machine learning. Anyways, so there's two different routes we can take here. One's called supervised learning and one's called unsupervised learning, okay? And let me go, the next slide here is actually gonna make it pretty clear. This has been, for me, this whole supervised, unsupervised was really confusing for me for quite a while. I couldn't wrap my head around, why would you ever want to do this unsupervised learning? So it actually makes a lot of sense to me now. So with supervised learning, okay, oh, look at this like AWR data right here. We got snap IDs, and these are some statistics right here. User calls per second, average active sessions, stuff like that. Okay, the data sets here, I'll just say the Oracle data is exactly the same right here. What's different in these two little pictures right here is with supervised learning, we have an additional column. And the column's called a label or a target. And what we've done, we've used some external system to actually actually to record the user's experience. Was performance bad or good? And there's only two options here. The way I created this was good or bad. It could be green, yellow, or red. It's whatever we want the labels to be. And they're going to be some discrete values. So there's usually only a couple, like green, yellow, red, good or bad, that kind of thing. And the trick here is that these attributes of performance produced a bad experience for the user, okay? This group of performance or Oracle activity produced a good experience for users. Okay. Now, I'm not going to get into this in detail today, but finding the label is one of the most difficult things for DBAs to do, because some of you are already thinking, oh, I can just do some math and I can figure out if it's good or bad. Right? I'll multiply user calls by 5, average active sessions by 10, because we know that's really important, and do that kind of thing. Okay. That thinking is totally messed up with machine learning, because if we can just do math to determine what the performance is going to be, you don't need machine learning. You just need some really cool rules. And we all know that doesn't end well when it comes time to scale. So you have to fight. I teach online courses. I'm right in the middle of one of my machine learning classes right now. And it is so difficult for us DBAs to actually not try and do math to come up with the label. So where do you get the label? It could be like a ticket, or like a support ticket system. So, when this was the attributes of performance, we got a ton of tickets. So performance was bad. Users were not happy with the experience. So you get this from an external system. Notice the question marks down here, okay? What we're going to do is supervised learning. We're going to train our model. We're going to give it this data, and we know the answer. We know the outcome. And I'm going to bring you through that process. We're going to use decision trees to actually train our model. And then we're going to take it further, because we're going to look inside the decision trees, because that's where all those if then else statements are. But for the most recent snap, the users haven't started calling yet, right? They might, but what we want to do, based upon the model that was created, we're going to say, okay, model, this is what just happened. Are the users going to call? And the model will tell us good or bad, green, yellow, red, that kind of thing. And if it's like red, it's like, hey, they're probably going to call. We need to look very closely at this one system right now, as opposed to all the other things that you could be doing right now. And that's really the value. And so this is called supervised learning right here, because we have a label. Unsupervised learning, you'll notice there is no label. Or if there is a label, we're not using it. what you do with unsupervised learning is that you basically, and I have a presentation on this too, it's great for anomaly detection. Essentially what we're doing is that we're looking at the data right here, okay? In fact, let's just focus on anomaly detection. Let's say I build a cluster of points. Okay, picture a cluster with all the data right here. Okay, then I say, hey, where all the points, where's the most recent snap ID in this cluster? So I look at I got my cluster and I say, where is snap ID 105? And maybe the point's like way out here. And we're like, whoa, all the other points are like over here. The most recent snap point is way out there. That's really different. That's highly unusual. That's anomalous. And so we say, that's unusual performance. We better check it out. Now, it could be really good performance. It could be really bad performance. What this is about is it's really, really unusual and we need to check it out. And so that's how you can use unsupervised learning, because we don't know if performance is supposed to be good or bad. We just know that it's highly unusual. So if you have these two different systems working, it's gonna be rock and roll fun. All right, so that's really the difference between supervised and unsupervised learning. And one of the models or the algorithms that we use for unsupervised learning is clustering. And that's what I just described when I tried to describe with the clustering there. With supervised learning, usually what we're going to do is called classification. We're going to deal with classifiers. All right, that's what a decision tree is going to do for us. And the classification means there are classes, there's discrete classes like green, yellow, red, good or bad, true or false, that kind of thing. Okay. If it's regression, it's more of what we've done for many, many years. The prediction is maybe CPU utilization, 50.4%, 80.2%, that kind of thing. Whereas classification, it's green, yellow, or red. Very, very different. Okay. Anyway, so that's the difference. So what we're going to focus on is machine learning, supervised learning, classification, and the next level is that we're going to use what's called decision trees to actually do this. Okay. Hopefully that made sense. That was one of the, it took me forever to really understand, because all my background in capacity planning and prediction, I always had this label. I always knew what that was. Okay, okay, let's talk. Okay, I'm gonna skip this right here. All right, because I want to get tons of time for the demo. So, okay, so let's actually do this. We're gonna use what's called decision trees. So what I'm gonna do is that we're gonna build a decision tree to make predictions. And here's our data. Okay, so I have two columns here, two attributes of performance. In machine learning, you don't use the word columns, you don't use the words attributes really, you use the word feature. Yeah, that's half the challenge of learning machine learning is the words that you already, right? It's like they change the words to describe the same thing that we've done forever. Okay, that was like, you're kidding me. I see that repeatedly in machine learning, especially with my background in predictive analytics. It's just like, oh, you just have a new name for this. It's like, come on, man. Yeah, well, I guess you can charge more that way, huh? Anyways, so these are our two features, average active sessions and CPU utilizations. And the label, right, the outcome is it's going to be either good or bad right here. And so I come up with some algorithm, okay, and this is why I say Craig's algorithm, because I came up with the algorithm. So what we're going to do, and here's this reminds me of school, right? Don't look at the rest of this. We don't want to distract you here. Is that we're going to take our training data. We have like five samples, and we're going to build out a decision tree based upon our algorithm and the training data that we have right here. Okay, so this is how you do this. So my algorithm says we're going to focus on average active sessions first. Then we're going to focus on CPU utilization, and then we're going to go back to average active sessions. And so what we need a decision. We need a decision rule right here. So I did some math so I could come up with some threshold. Okay, so what is this math, right? I mean, how did I come up with that? That's my rule. That's Craig's decision tree rule right there. So I know whether I go left or I go right, yes or no. And so if you look at the previous slide, the rule is of all the data that I'm considering here, that I'm working with, I take the lowest value, which is 4, and the highest value is 14, add those two together, divide by 2. It's like the average, all right? Well, I guess that's not the average. Yeah, the average, sorry guys. Well, that's not really the average, but anyway, I took the high and low, add them together, divide by 2, and that turns out to be 9. So that's my decision rule right there. So now we're gonna look at our first piece of data right here, our first row, okay? And I'm gonna say, hey, is 4 less than 9? Well, yeah, of course it is. And so I'm gonna put my sample number 1 over here, and its label says that performance was in fact good. And this is not a prediction, this is what actually happened based on, let's say, tickets submitted, that kind of thing, okay? Now let's look at the second row here. So we're still looking at average active sessions, but we say, hey, is 6 less than 9? Yes, it is. So it goes over here, and its label is performance was actually good. Now we go to the third sample here. We say, hey, okay, average active sessions is 10. Is 10 less than 9? No, it's not. So we go down to the right, and that's our third sample row right there, and its label is actually bad. So we go to the fourth row now, and average active sessions is 14, and we say, hey, is 14 less than 9? No, it's not. So it goes to the right, and its label is also bad. We go to the final one right here, final row, and average active session is 12. We say, is 12 less than 9? No, it's not. So the fifth sample goes here, and its label is actually good. Okay, so here's the cool part. On the left here, all of our samples here are labeled with good performance, which means anytime we get down to this node right here, the answer, the predictive answer will be performance is going to be good. So if we get some data we haven't seen before, and they have actually, I don't know, the average active sessions is 8, and somebody says, Craig, so what's performance going to be? I'm going to say 8's less than 9. It's good. It's going to be good. Well, what about all the other stuff? No, it's going to be good. That's what the decision tree says. So that's how we use a decision tree. But let's say average active session is 20, and I'll say, well, since I go down this branch, well, it's more likely to be bad than good. So I'm going to have to go with bad. Okay. Fortunately, the algorithm is not satisfied with this because it's not like fully qualified. So we're going to go down another level in the tree. And now we're going to focus on CPU utilization. Now we only have 3 more sample rows left to place in the tree, right? Because we've already taken care of 1 and 2. So we're just looking at 3, 4, and 5. So again, I take the low value, the high value, divide by 2, and that's my rule. So now I say, let's look at the third row here. I say, is 50 less than 55? Yes, it is. So we go to the left, and there's our third row, and it's labeled as bad. We go to the fourth row, and its CPU utilization is 60. Is 60 less than 55? No, it's not. And so row 4 is there, and it's labeled bad. And our final row, CPU utilization is 54. And of course, that goes down here because it's less than 55, and its label is actually good. So now on the right here, this branch is fully qualified. It's only B. Yeah, there's only 1, but it's only B. It's only bad. So if I navigate down here, I will always say, hey, performance is actually, it's going to be bad. Okay. Now you'll notice this is not qualified yet, fully qualified again. So I'm going to go down yet another level. I'm not going to walk you through that, but you guys get it. So what we have here, we have all good, all bad, all good, all bad. That's what we actually like to see. But sometimes there's limitations on the time it takes to build out a tree. We get data that's actually kind of conflicting, and a number of other reasons why we're going to have to end up with something that's mixed, like good or bad. And you'll actually see that when I take you through the demo. Okay. All right. Now, the super cool thing about this, once we've loaded this thing with all of our data, which of course could be thousands and thousands of rows of snapshot information, right? Just depends on how much AWR data you have and you're willing to work with. What this basically equates to is code, a bunch of if then else statements right here. And let's just pick the first one here. Okay, if average active sessions is less than 9, yeah, is 4 less than 9? Yes, therefore performance is good. If it's not, then I'm going to have to go down the rest of the tree and actually figure it out. So essentially, this information is actually embedded within the decision tree itself. So what I'm going to show you how to do is to actually get this information out and also make it as simple as possible. So we don't just have like, you know, thousands of lines of decisions. Yeah, and what you'll, and even if you don't actually like, you know, deploy something like this, you will learn an incredible amount about what really matters from a performance perspective or from a user performance perspective or a user experience perspective. And so when we go through the demo, you'll quickly see what really matters to the users. Okay, it's kind of cool. All right, so can we make this better? Oh yeah, I mean, there's tons of ways to make this better. I'm not going to go through these. This is just some of the stuff that we actually talk about in my machine learning class. All right, so let's go stealth mode. Okay, now you guys are going to be able to do everything that I do, but in order to do that, you have to have like a little machine learning sandbox set up. You got to have Python, super easy to install this thing. And it's not only Python, you get all the machine learning libraries are actually loaded on your box as well. You can do this on Linux, you can do it on a Windows or a Mac. I've actually done this on Linux, but I've never done Linux with the graphics before. I've only done on a Mac, and my students, usually it's kind of half and half Mac and the Windows. Anyway, this is a blog that I did right here, a blog posting. That'll tell you how to get your sandbox ready. That's a long URL. So if you just go to blog.orpub.com, just search for sandbox and you'll see it. That's all you actually need to do. Okay. All right. So if you actually want to download like the slides and what's called the notebook, which has all the Python code. Okay. If you actually want to do that, you need to go to orpub.com. You have to log in. So when you have to at least be a free OraPub member. You know, you look for the free membership button, click it, and then you'll get a log on, and then you can actually get, you know, download all this stuff. All right, so that's what you need to do. Of course, then I'll like to hammer you with marketing stuff and all that. No, I won't do that. Okay, these are my demo failure slides. In case there's something really bad happens, I can walk you through this thing, but it's way more fun not to look at the demo failure slides. So what we're going to do, I'm going to take you to what's called a notebook. Now, this is not a Python class, and I'm not a Python developer, you know, anyways, but we need to know at least a little bit. Okay, so we got 30 minutes left, which is awesome because this is going to give us plenty of time to go through this. So again, if you got any questions, any bizarre machine learning questions, go ahead and chat those in, and I'll do my best to answer. And you can always email me as well too. All right, so what are we looking at here? Okay, this is called a notebook. Okay, notebooks are not a new thing. I first used a notebook using Mathematica, I don't know, probably almost 10 years ago. And I really didn't realize that they're used for like programming. I just thought it was a Mathematica thing. No, they're used all over the place. In machine learning, what's called the Jupyter notebook is going to be the industry standard right now, but there are many different vendors that do notebooks, but Jupyter, I would say, is the industry standard. Also, you'll notice I'm using Python and not Oracle. Okay, you're probably okay. So here's the short answer on that. Okay, Python is the industry standard right now. That's just the way it is. Okay, and so that's why I'm using Python with the Jupyter notebook. When I started, you know, taking advantage of all the new predictive stuff that was available, which led me into machine learning. I learned it using R, the free statistics package R. But in talking with Oracle, they said, yeah, we're going to support both R and Python, but it looks like Python's going to win. And I remember that conversation. I'm like, oh crap, I got to learn another like programming language, man. They're like, well, yeah, probably. And I said, are you sure it's going to be Python? They said, yeah, it's probably, but we're okay if it goes either way. And then it's like, boom, this went off in my head, and it was like, this is just like Linux versus Solaris. Oracle doesn't care which way it goes. They win either way. It's the same thing with R and Python. But it looks like, you know, Python's winning. And if you talk to people that do like actual data scientists, especially that do projects for multiple customers, they're going to say, yeah, it's going to be Python. Okay, not R, not R. Although a lot of it's more, I'll just stop there. So, but okay, but still, why not Oracle? Okay, Oracle has a really good argument. Argument sounds confrontational, but they have a really good reason why to use SQL and PL SQL. Most of the the data resides in Oracle, and so their reasoning is, well, don't actually pull the data out of Oracle to your desktop in Python. I mean, what a crazy idea that is. If you have a lot of data, that's going to take forever, and it's not good for anybody. Why not just take the algorithms, which most of them have already been in Oracle for years, and just put the algorithms like in the database, and so we can operate on the data directly in the production environment, because that's where the data is. Sounds really good, right? Now, some of you are like, oh, wait, Craig, did you just say do the number crunching machine learning stuff in production on a production server? And I did say that. Yeah, that makes me feel very uncomfortable too. Okay, so there's a rub there, and you have to kind of figure that out. Now, in the kind of projects I do, which is for IT, to help IT, not, you know, it's not finance, it's not sales and marketing. The amount of data that we work with is minuscule compared to what a big data science project, machine learning project might be. We're dealing with AWR, ASH data, stuff like that. So we're not dealing with gigabytes and gigabytes and gigabytes of data. So it's not a big deal to get the data, to bring it down. You can actually interface with Oracle directly really easily in Python. You can load the data right in to Python in memory, and you can do all your number crunching and stuff like that on your desktop or on a little dedicated box, VM, whatever. Okay, so that's a little bit about Python, Oracle, Jupyter notebooks. Now, notebooks are a fantastic learning and development environment. I mean, it's amazing. All my class, well, my machine learning class, it's all notebooks right now. There's no big text files. Okay. By the way, you can export this, download as just, you know, text and or Python, just raw Python, and all the stuff that's not Python is commented out. Okay, so that way you can deploy this. You can move it out of a notebook. Now, what's key about notebooks is everything's divided up in cells, and you can just kind of see there's a cell, there's another cell, another cell. And instead of running the whole program top down, you evaluate or run one cell at a time. And so that way you can, if this code is messed up, you don't have to go through all the other stuff, right? Or if something's messed up, it'll stop, you know, so you can work on it very in small pieces, which is really, really cool. So to evaluate one cell, you just make sure the cell's highlighted and you press the little run button right here, and boom, loading, done. You can see I printed loading, loaded some libraries, and then I printed done right here. Okay. You can also, and this seems to be the case with most notebooks, if you press Shift Enter, boom, it evaluates also. Okay, and you can keep reevaluating. It's not a problem. Okay, all right. So what I did, I just loaded some libraries here. Okay, now we're going to do two demos here. If I use my time wisely. One is super small, so we can understand exactly what's going on. The other one is actually going to be real live Oracle production data. So it's super cool, or an extract of production data. So this is basically where we're going to set everything. So you'll need to set this yourself depending upon what you want to do. So we're going to use what I'm going to call the small data set, okay, which only is like, what, 12 rows of information, and I actually created the data. The real data set is based on sysmetric summary, DBA HIST sysmetric summary. And so we're going to have not 3 features, we're going to have 161 features, which is awesome. Okay, pretty cool. All right. And we'll talk more about what do I mean by all that and why so many and all that. So I'm going to put a limitation on the decision tree. I only want it to go a depth no more than 4 deep. And it starts with like 0, 1, 2, 3, 4. So it's almost like 5 in a way. Okay. But with our small data, it's not going to go for. The reason you might want to do this, especially with what I'm talking about here, is that you won't have as many if then else statements. The tree is going to build out this way, but it's actually not going to be able to fully qualify, right? What I mean by fully qualify, it's not going to be able to fully qualify with all of our data. So what I mean is, you could easily end up with a situation where it's both bad and good. It's not all good or it's not all bad. Okay, that can easily happen, but we're not going to have thousands of rules of if-then statements. And so that's going to be important when you look at real data. I always set random numbers so I get consistency when I rerun the thing. Okay, now what is going to happen? Another way to keep the tree small is to reduce the depth. Okay, the other way is to reduce the number of features or attributes of performance, columns. Okay, so 161 is awesome, but we're going to have like a lot of rules. And if you're actually going to try and understand what's going on, or actually take this and put it into an existing monitor system, unless you generate the actual code, you're not going to be typing this stuff in. It's going to be a nightmare. So one of the ways to reduce the complexity is to reduce the number of features. Okay, now the question is, now if I want to reduce the features, which features do I get rid of? How do I just keep the most important and powerful predictive features? Machine learning has an answer to that question. And so we will actually reduce the number of features with just a few lines of code. And this is how many features I'm going to reduce it to. Now, it's not going to make any difference when we start with 3, but when we have 161 and when we reduce to 4, it's going to make a big difference. And this is also there. It will quantify which features are the most important. And it's really cool to look at your real data when you actually do that. You'll learn a lot. Okay, and the rest of this stuff is that scoring stuff. We're not going to care really about scoring or determine the accuracy of our model. That's kind of out of scope for today. You're going to need to change where your data is going to reside and where any charts that are created, where that, you're going to have to change that. So just put it on your desktop or something like that. Okay. Okay, so let's evaluate this. Done. Sometimes I put it done at the end so I know the cell is done evaluating. Also in the upper right hand corner, the little circle here, when I don't know, let me see if I'll reevaluate this. Oh, you didn't even see it. Okay, it happened too fast, but that'll be solid when the CPUs are burning. Okay, so what I'm going to do here, we're not going to go through the detail on these, but this is just scores our model determines one way to determine the accuracy. What I want to highlight though is that almost everything I do in Python now, I create, it's all function based. So I create a function. This is how you create a function in Python. It's this define right here. Python is very sensitive to spacing. If you ever learn Fortran, it's kind of like that. You think, that's going backwards. Well, actually, it works pretty good. You'll notice there's nothing that says like end function. It just knows that there's no spaces here. So I'm back to the first column, and therefore the function is done. So it will take all of this as the definition of the function. Okay. What I usually do is I define my function and then I test it. I have a little test statement right here to actually test the statement. So it's a great way to actually develop the function, and the testing is right here in the cell itself. And all I got to do is set essentially this Boolean variable testing to either true or false. So up above here, it says testing is actually true. So when I evaluate the cell, it not only creates the function, it will actually do the testing for me. And then you notice this if statement, there is no end if. No, it's when I'm back to the first column. And so regardless of whether I'm testing or not, when I run this cell, it's always going to say, you know, done when it gets through here. So let me evaluate it, shift enter. It's doing the testing. That's what the scoring is. And it's number crunching. See that right there? Man, there we go, done. Okay, and I'm not going to tell you, we're not going to talk about what that means. Like, don't look behind that curtain. We don't care about that today. All right, we're going to use our small data set. So this is the CSV file. If it does not find this on in your directory, it's going to go out and get it right here. Super cool. You don't have to say, okay, you got to make a HTTP call. When you actually just read the CSV file, it knows. It says, oh, that's an HTTP call, and Python just goes out and gets it. Super cool, right? You gotta love that. All right, this is how we doing on time. All right, here's this. What we're gonna do, we're gonna read our CSV file. We're gonna load it into this this structure right here. Okay, this thing is called a data frame. Think table. It's got rows, it's got columns. The columns are called features, but they're named just like we name all of our columns. So I could have called this anything I want to, but I usually put a suffix of capital DF so I know it's a data frame as opposed to an array. Arrays are very different. Arrays are very different than data frames in Python. And for machine learning, you have to be really careful about this because the machine learning algorithms want numeric arrays. They do not want data frames. So, but it's easy to convert back and forth, but that's a big deal. So I load the data into a data frame, and this is going to give me the shape of the data frame. The shape is simply the rows in the columns. This is how I check to make sure like I haven't completely hacked my data, okay, by looking at the shape of it. All right, then what I'm going to do is I'm going to do some cleanup here, and I'm not going to get into what I'm going to do, and but I'm going to do some cleanup. All right, there's the shape right there. That's how many rows I have, and that's how many columns I have. Okay, not super exciting. Let's see when I'm done. Rows, columns. How come that says 3? Oh, that's my sysmetric. I wonder if I already ran this thing once. Oh, no. Okay, I'm not going to get into that right now. There's a reason, and I just don't want to do. I don't want to get into that rabbit trail. Okay, this is important for us to understand. In machine learning, we have to fully denormalize. Okay, I know we've all taught about normalization and the beauty of that, all that kind of stuff. But what we need is we need a snap ID, like it's like basically a key, and then every feature, boom, boom, boom. So, but when we get data, like with sysmetrics, there's going to be a snap ID. We got the name of the metric and then like the value, and we're going to use the average. And that's nicely normalized. So what we need to do, each one of these metric names is going to become a column. And then the value of the column is going to be the average here. And so we essentially pivot or we denormalize. There's actually a pivot function right here, which is going to do that for us. And so we're going to denormalize. And so we originally had like these 6 columns or these 6 features right here. Okay. And I reduced them to 3 and I up above. Okay. And when we denormalize, notice the metrics here. There's 3 metrics: average active sessions, CPU seconds, and IO reads. Now we've denormalized, we've pivoted, and so now we have 9. We have 9 rows, 1 row for every snap ID, and we have 4 columns: snap ID, average active sessions, and so on. Okay, so that's really important. Now, in what we're doing here, we do have labels. We know whether performance was good or bad. Okay, so what we've done here up above is we've loaded the feature data. We've loaded attributes of performance. Now what we're going to do, we're actually going to load the data itself. Or I'm sorry, we're going to load the label data right here. All right, so And so this comes from a ticket system. So we're going to load that. And there's our tickets per snap. Okay, this is like, the average, the mean and all this kind of stuff. What we need to do, we need to convert the numbers here, the rates, to our labels. And our labels are going to be yellow, red, or green. And so I'm using some thresholds here to determine what the labels are going to be. How did I come up with those numbers? Usually exhausting meetings and looking at some statistics and histograms is how I come up with the thresholds. Okay, so that's the answer. So it turns out we have 4 yellows, right? Samples, we have 3 greens, and we have 2 reds. That's the situation. All right, now we're going to kind of clean things up a little bit. Now this is how we're going to determine the most important features, right? I said we may have like 161 features, but we want to reduce it to 4 to make things understandable. This is how we're actually going to do this. Okay, right now we're not actually we only have 3 features anyways, so it's like not a big deal. It's not really changing anything. But look at what happens when we do this here. Okay, these are the 3 features. We only asked for 3. We only had 3 anyways. Okay, but you see the numbers right here. What's the most important feature? What really matters? Well, CPU seconds matters the most, and pretty closely followed by IO reads. Average active sessions doesn't really mean a whole lot, but we still have data for that. So you could say, you know what? I just want to use 2 features. And that's actually the process that you actually go through with this stuff. All right, so let's actually, all right, so what we're going to do, okay, we're getting low on time here. What we're going to do now is that we're going to create the model here. Wait, hold on a second. So data. Yeah, okay. So in Python, there's a machine learning framework, okay? And without getting into it, it always follows the same kind of process. We load the library and we initialize the model. And then we're actually going to load the data into our model, and that's called fitting the model. And then we can make predictions. So you load the libraries, you initialize the model, you fit the model, and then you make predictions or something like that with the model. Okay. Initializing the model is like creating a cursor. Like the cursor's been created, but we haven't fitted the SQL text into the cursor, but the memory's been allocated. Right? It's followed the code that's in all the Oracle libraries. So yeah, that's how I kind of look at it like this. Okay, so this is my decision tree classifier, and there's my initialized model right here. Okay, and then I'm going to do some scoring, but we're not going to worry about that. The trick here, or the key, is I initialize the model. Okay, now just for fun here, let's look at all of our data right here. Okay, so there's our features with the snap ID, and there's our indicator. Or our label, which is going to be yellow, green, or red. Okay, now we've actually initialized the model. What we're going to do now is we're going to fit the model. We're going to take this data, we're going to load it into the decision tree. It's the same thing that I did manually, but it's going to do it for us. Because if you look at here, we're going to take our initialized model and we're going to fit it using our features and our label data, which is all this data right here. By the way, it's super confusing until you're used to this. The feature data, we usually just use a capital X for features and a lowercase y for the label data. That's just the way it is. Get used to it. That's all I can say. But because you guys aren't used to seeing this, I actually put X and I added the word features so I know, so we all know what we're looking at right here. So we're going to initialize the model, and then we're going to fit it using our data. And the result is a model that's been fitted. Now, inside this fitted model, that's where the if-then statements are. That's where they're at. And so we're going to export that information, and then we're going to print it. So here we go. There are the rules. Super cool. Okay, this is awesome. All right, so I think it's awesome. So let's look at the data right here. Okay, so the question is IO reads less than 50? Okay, is IO reads less than 50? Yeah, it is. It's only 10. Okay, so that means now, then we're going to look at this data right here. Is average active sessions less than 55? No, it's not. It's 100. Okay, therefore, all right, so it's greater than 55. Guess what? Performance is going to be red. Boom. And that's actually what was loaded into our decision tree. And so we just work our ways through the rules. Okay, well, that's pretty cool. I get that. All right. But what if we had a picture? So when I evaluate this cell inside, it for some reason doesn't show up anymore in the notebook, and so there must be some setting. But it created a PDF for me right here. Check this out. Now here's a visual way that we can actually see the rules. Super cool. So there's the rules right there. You see the IO reads less. Okay, I have 9 samples, and these are the values right here. So you need to know what's 3, 2, and 4. Well, that adds up to 9. And to kind of help us out here, I put the order right here: green, red, yellow. Okay, so we have 3 greens, 2 reds, 4 yellows right here. And so this class, what this means is, well, if I had to choose, what's my best bet? It's going to be, well, I got 4 yellows, so we're going to say yellow. Okay, but luckily we can go down further. By the way, you see this little Gini stat right here. When we fully qualify a node, that's going to be 0. So that's what we really want. So if you look way down here at this branch, Gini is 0. We have 3 samples, and you can see they're all green. So if we make it down to this node, the answer is green. Okay, and so you can see we're able to qualify completely on all of the nodes right here. So we get a nice picture. And you're thinking, okay, that's cool, but what if I want to create code? Not a problem. That's what this function does right here. So there's the function, and I'm actually going to call the function right here. I'm going to give it my fitted model and my feature list. That's what it wants. All right, and so when you run this, boom, there's the code right there. Now, you guys are DBAs, you're developers. It's not rocket science to make this code look by just modifying a few lines here. So you can create PL SQL code, C code, I don't know, whatever monitoring system code you need to do, you can do that. So now you actually have code that you can actually potentially use. Now, that's pretty cool, but I want to bring us back up, and then we'll do the full-on demo here. What we have learned here is that looking at our data, this is the most important feature. What impacts users? What impacts the user experience the most? According to our data, it is CPU seconds. So, and then IO reads is closely followed. So if you don't actually, implement the if-then rules and do all that, you might want to take a look at your monitors and see if they're really keyed into CPU seconds or IO reads. So that is a definite takeaway benefit that you can grab from this right away. Okay, now let's go back up again. Okay, and I'm going to restart and clear everything here. So this is basically, I'm going to start over. It happens in just a second. All right, so I'm going to reload the libraries. Okay, done. Now we're going to use the real data set. So we're going to uncomment. We're going to just do that. And I still want to keep, let's not use, okay, we're going to use 4. And we're going to say, hey, we only want to use 4 features. We're going to take, because there's 161 features in Sysmetric summary, and we're going to reduce that to just the top 4. And then I'm going to do the whole thing again, but we're just going to let it go crazy. All right. And so, okay, so we're set there. I'm just going to walk through the whole thing. I'm reevaluating here. The click, I'm hitting Shift Enter. So I think I am. It's running. I'm kind of got ahead of it here. Blah, blah, blah. What's it doing right now? Okay, it's doing here are the, okay, this is real production data, so your data could be different, but look at the top feature right here. By far the top feature database time per second. Is that a surprise? Probably not for you DBAs, so you focus on performance. Far below is this physical writes total IO requests per second kind of thing. Super cool, huh? There, that's the big one for this system. All right, let's actually, here we go. Okay, here's the rules. There are the rules right here. So I have like 1,200 snaps, something almost 1,300 snaps right here. So these are all the rules. Yeah, okay, really interesting. I know, there they are. Let's create the tree. So I go back to my directory right here, and now look at the map this time. A little more interesting, huh? Check it out. And we can zoom in, but it's still the same kind of thing, right? DBA. There's my. There we go. And I got a bunch of, greens wins, but it's, I got to go way down. So if I go all the way down here, okay, now you'll notice sometimes it's fully qualified, but sometimes it's not, right? There's more greens here than there are, what's that, yellows, but green wins. But it could be yellow according to our model, but we weren't able to fully qualify this because we limited the depth to 4. He says no more. No more. And so this is what's going to happen when we put limitations. Here's one though. If you get down to this block right here, or branch, or this leaf block, it's always going to be yellow. Okay, here's a situation where it's probably red, could be yellow, so we're going to go with red most of the time. Okay, all right, 2 more minutes. Oh, we got the code. We're going to skip the code. Who cares about that? Okay, we're going to let this thing go wild right here. So real data. We don't care about the depth. Let it go to 40. How many features? Let's cut it down to like, I don't know. Let's do 20 features. Okay, so we're going to run this whole thing here. Boom, boom. Actually, I could have just had it automatically run the whole thing for me. Okay, bunch of features. All my sysmetric data. Here we go. Okay, so now there's the most important 20 features. We still have database time per second, and then it goes, but you can see it drops off actually pretty darn quick right here. But these are the features that are going to be included in the decision tree. So we're going to go through all this. There we go. Okay, so now let's show the rules. Oh, look at that. The rules, there's a lot of rules now. It's not super deep, but look at all those rules. Keeps going, going, going. All right, let's get a picture of that. Okay, it's still creating the picture. Done. Okay, let's take a look at it real quick. Check it out. Wow, there's our decision tree right there. Different levels. And of course, if we zoom into this, it all goes to the same kind of stuff that we were talking about before. It's either green, yellow, or red right there. Okay, and that's a PDF and whatever. Okay, let's look at actually the rules itself, which you can then create the code for you. There's your code right there. That's all your if then else's are right there for you. Put that in PL SQL. That'd be pretty cool to do that. Maybe someday I'll actually do it. I haven't actually done this in real, for real. It's just, it's almost like a concept presentation to get you guys thinking and excited about this stuff. So that's it for the presentation. All right, so we did our stealth mode. Let me skip down to the demo. All right, so what do you do if you want to go deeper? Or pub membership. I got LVCs specifically on machine learning. The next one's going to be in 2021. And don't forget about the machine learning e-course. Of course, the LVCs, and that's it. So I hope I whetted your appetite for machine learning, and you can see that there are a lot of different ways that we can use machine learning in some very untraditional ways. And if you've ever got into decision trees, you probably wondered, well, where are the rules? How do I get those rules out of there? Can I look at them? Yes, of course you can. And I showed you how you could do that. So hope you got something out of this, got some value. And thanks for listening and watching. That's it, Monica. Coleman.
Awesome. Thank you so much, Craig. That was a super fun presentation. I wish we had more time with you. And I have to apologize to everyone. I just noticed that the questions panel was not up. So I just turned it on. If you want any last minute questions, if it pops up, go for it. Otherwise, you can definitely send us questions for Craig and we'll shoot them all over to him and see if he's got some time to answer anything.
Oh, yeah.
So my apologies, but awesome webinar. Thank you so much for your time today. Thank you, NYOEG, for co-hosting with us on this and many other webinars. So everyone, please go out to viscosityna.com/event for more webinars like this. You can also go to nyoeg.org and I'll send you information on how to reach out to Craig and check out AuraPub. So thank you again. Again, if you have questions, you can even respond to my email that you'll see after this. We will have a recording out to you, so give us a little time for that to render, and otherwise you should be set. So thank you all so much. I hope you have a great day.
All right, see you guys. Thanks for watching.